Hi guys, welcome back. Today we'll be doing question 8, calculus. 8.1 says determine the first derivative from first principles if f of x is equal to 2x squared minus 5x. Okay, so since it's from first principles, we're going to write down the first principle formula. Okay, next we're just going to substitute our values in. So f into x plus h represents the first x in the equation, which is that x squared. Okay, so all we have to do is adjust the equation to emulate what is in the question. Okay, so before the x we have a 2, so we're going to put a 2, not forgetting to put our lum h to 0 down. So 2 into x plus h, and the x is squared, so we're going to square that bracket, minus, and f of x represents the entire equation, so we're just going to simply put the entire equation down, all over h. Okay, it's important to bring the lum h to 0 down in every step you do until you actually substitute 0 within the equation. Okay, so for now we're just going to simplify this equation. We're going to multiply the bracket out and multiply the 2 within in one step. So we'll get 2x squared plus 4xh plus 2h squared minus 2x squared plus 5. Okay, all over h. The next step here is to simplify the equation as much as possible. So the 2x squared will cancel out to the negative 2x, and all the others are unlike terms, so we'll bring it down. 4x plus 2h squared plus 5 all over h. In this case here, we are unable to take out an HCF on the top so that we can cancel it with the bottom and get rid of that h. Because as is, if we substitute 0 within, there will be a 0 here and it will make the equation undefined. Okay, so we can't have that, so we need to simplify it a little bit more. So the one method we would do this is we would take out h, an HCF of h on the top, and that would cancel out at the bottom, and our problem is solved. In this case here, we can't take out an HCF of h on the top because this 5 does not have an h attached to it. So what we're going to do is we're going to split each one with the denominator. So bringing h, lum h to 0 down, 4xh all over h plus 2h squared all over h plus 5 all over h. Okay, from here we can see that most of them cancel off, and what we're left with is something which will not cause us to have a undefined equation. Okay, so just rewriting it, 4x plus 2h plus 5 all over h. Okay, from here we're going to substitute our 0 within, so 4x stays the same, plus 2 into 0 plus 5 over 0. Okay, the rest of it, the equation remains 0, only 4x comes down. Okay, and that's how we derive from first principles. 8.2 says evaluate dy all over dx if y is equal to x to the power negative 4 plus 2x cubed minus x over 5. Okay, so let's just go and rewrite that equation here. 8.2 y is equal to x to the power of negative 4 plus 2x cubed minus 5 over x. Okay, the first step in any derivative derivation is to simplify the equation as much as possible and try to get x to be as linear as possible. Okay, so x to the power negative 4 will stay like that, plus 2x to 3 minus, and anything on the side, this is supposed to be the other way around. Okay, so anything on the top of the equation is the same thing as having it on the side. So we can take this as 1 over 5x. It means the same thing. Okay, from here, we're going to start our derivation where we say the exponent times the coefficient. Okay, so negative 4 times positive 1 is negative 4. Rewrite the x and we minus 1 from the exponent. Okay, which will give us negative 5. Same thing here. 3 times 2 is going to give us positive 6. Rewrite the x, minus 1 from the exponent, and we get it squared. Same thing here. The exponent, which is 1, times the coefficient, which is negative 1 over 5, minus 1, x to the power of 0 is 1, and we just leave it like that. Okay, so that's how you derive from first principles and from your normal rules of differentiation. 8.3 says, given the equation of g of x, calculate the first derivative of g for x is not equal to 1. Okay, so let's go and do that. 8.3.1, I'm just going to rewrite the equation. G of x is equal to x squared plus x minus 2 all over x minus 1. Okay, so determine the first derivative of this equation. What we're going to do is try and simplify it as much as possible, because we know that this bottom here is unfavorable. It's not a linear equation, and we're trying to make it a linear equation. So from the top of the equation, we can see that it follows the order of a trinomial, where it's x squared, x alone, and a constant. So we can go and break that up into two brackets with x and x, and the two values which will give us negative 2 and positive 1 is obviously going to be positive 2 and x is equal to negative 1. Okay, and we can see here that the top and the bottom one cancel off, so that and that, and we're only left with x plus 2. Okay, from here, this is still g of x. This equation has not changed, it's just been simplified. Okay, to determine the first derivative of this equation, we're going to do the same thing we've done in the previous question, where we'd say the exponent, which is 1, times the coefficient, and then minus 1 from the exponent, and x to the power of 0 is 1, so 1 times 1 is 1, and the derivative of any constant is automatically 0. So our answer in this case here is 1. 8.3.2, it says, explain why it is not possible to determine the first derivative of g of 1. Okay, so basically when x is equal to 1. So they're asking, why was this restriction placed on the graph or on the equation? Okay, so it was placed on the equation because when x is equal to 1, this bottom part becomes 0. So if we had to substitute 1 within, we'd see that 1 minus 1 will give us 0. And anything divided by 0 is obviously undefined. So the function is undefined when x is equal to 1. Therefore, it's not possible to determine the first derivative of it.